The Arduino series has been a staple in electronics prototyping for well over a decade. Now in 2020, a new Arduino device, the Arduino Portenta H7, has joined the series. This aims to be one of the most powerful microcontroller platforms on the market. So today, we'll take a look at what sets it apart from the Arduino you might already know. I should go on to note that I'm not affiliated with Arduino in any way, other than being a satisfied customer for many years. Right off the bat, the new solder mask and the new form factor indicate that this is something with a new end use in mind. It also boasts some very powerful specifications. Most of these were printed right on the back of the package. The circuit board uses a very high density layout. Luckily, the design still uses plated through holes that can be used to expand the system or use it with a perforated circuit board. As always, I highly recommend doing any assembly work at an anti-static workstation. Generally, I consider this a good practice, and in my case, I'll be using an anti-static wristband and an anti-static mat on my workbench. This will avoid static electricity and hopefully help maximize the life of your project. Finally, if you plan on installing anything new, consider backing up any data that you consider important, including previous Arduino projects. The kit includes the Arduino Portenta H7 itself and a compatible flexible antenna. The antenna works with both Wi-Fi and Bluetooth, but it's also quite small, so make sure you look for it before you discard anything. The packaging also includes a link to the official Arduino webpage, which will show you exactly how to get started. The Portenta H7 gets its name from the STMicroelectronics STM32H7. The main processor, which is the largest feature on the board, has an ARM Cortex M7 running at 480 MHz and an ARM Cortex M4 operating at 240 MHz. To put that in perspective, the clock speed of a very basic Arduino, such as the Arduino Uno, is an 8-bit device operating at 16 MHz. When you upload your custom applications, which are called sketches, to the processor, you have the option of selecting either the M7 core or the M4. The platform also includes a radio for both Wi-Fi and Bluetooth 4.1. You can deliver 5V power through the VN pin or through the USB-C connector. This connector is used for programming and for debugging. Not only this, but because of the video hardware acceleration in the processor itself, the USB interface can also pipe DisplayPort video to an external display. On the bottom layer, we have two high-density connectors. These connectors can snap onto a carrier board, and the carrier board can supply you with physical connectors for USB, RJ45 for Gigabit Ethernet, CAN bus, audio connectors, DisplayPort, and other interfaces. According to the official Arduino website, Arduino can also customize your Portenta H7 to some extent. This means that you can make a special request for a different memory configuration, different crypto chip, or a different antenna system, and everything you see here is basically the default configuration. In terms of software and programming, the system supports 3 languages: the Arduino language, which is very similar to C++, MicroPython, which is designed for microcontrollers, and JavaScript. For low-powered machine learning applications, this also supports the TensorFlow Lite library. Fans of the ARM mbed operating system will also be pleased to know that this is also supported. Despite all these capabilities, everything that I was able to do today was done in the regular Arduino Integrated Development Environment, also called Arduino IDE. To get started, I plugged the Arduino into the USB port of my desktop computer. Arduino IDE needed to be version 1.8.10 or later. After downloading and scanning the latest version, I installed Arduino IDE version 1.8.13, making sure to also install the USB driver. With the application open, I navigated to Tools, then Boards Manager. I then searched for any official boards supporting the Portenta H7. In this case, it was labeled Arduino Mbed Enabled Boards. After clicking the nearby Install button, Windows will ask you to approve USB drivers. If everything looks okay, install the drivers, and be prepared to unplug and then replug the Portenta H7 so that it's recognized properly by Windows. I tried searching for the Portenta H7 on Windows Device Manager, and even after rebooting and trying a few other things, it never really appeared. The serial COM port, however, was listed. At this point, I decided to follow some advice I saw online, so I navigated to Arduino's mbed directory, and then I ran the Windows batch file called post_install.bat. This wasn't part of the official instruction, but apparently some people did get it to work. Back in Arduino IDE, I navigated to File, Examples, Basics, Blink. Doing this will populate the source code for blinking the LED. I then navigated to Tools, Board, Portenta H7, and selected the M7 core. Next, I navigated to Tools, then Port. This is where you should make sure that your COM port matches the port used by the Portenta H7. The first time I tried this happened to be COM port 1, but your COM port number could be just about anything. Finally, I clicked the Upload button in the top left corner, and despite that earlier trouble I had with Windows Device Manager, the application uploaded successfully and the board started blinking green. Overall, USB drivers do seem to be a common difficulty with Windows 10. I've had numerous other devices, including other evaluation boards and software-defined radios, have trouble with Windows 10 drivers, so I was expecting the unexpected. Arduino also makes a Pro IDE, and also an environment that's based on the web. Overall, getting started seemed to be easier than usual. So if you're looking for a very small system with a lot of hardware capabilities, this is definitely worth looking into. If you found this useful, be sure to like and subscribe. And if you have a general interest in electronics projects, robotics, IoT, and radio communications, be sure to join us on Patreon, where we have a monthly poll and lessons learned on technical builds like this one. And as always, have a great day.